Okay, so last time we learned how to control the current on a current boost converter. Now, before we are moving to the buck converters, I have a simple question, yeah? A simple question
Yes.
before we are moving. Why do you think is this diode here? This one. Why do you think it's here? Why do we need this diode here? Why do we need this?
Because you don't want that current that bouncing on the coil to go to the drain.
Okay, I understand what you mean. But what about if we are connecting a wire? I mean, why not a wire? Why not a wire? Why we need a diode actually?
Because you want the current to go in that direction.
It will go anyway. If you connect a wire, it will not go.
Yeah, but it will go on in the same way on the drain as well. With the same.
No, I know.
No?
Okay, I understand your confusion.
Okay.
You think if it's diode here, the current will flow only like that? This is a wire. This is a wire. It will be everywhere. It will be till here.
Okay.
You know what I mean?
Yeah. So it must be other reason.
I want to see how you see this.
I saw it like that. So
why do you think we have a diode here?
I see that only reason.
You have to step back.
Okay.
And see the big picture. If you don't have a diode, you have a wire, right? And what do you have on this circuit? You'll have this and this and this, right? So basically, you have the capacitor, yeah, connected straight to the drain. You understand?
Yeah.
Now, when you connect this capacitor, yeah, here,
straight to the drain,
where it's very high frequency switching, yeah, like 20 kilohertz.
Yeah.
This capacitor is extremely slow. You can charge it, discharge it, like, it's not that fast.
All right, so you use the diode to charge fast the capacitor.
No, I use the diode to separate the capacitor being connected on the drain. Because if I have a capacitor here, it will slow down my circuit.
Oh, okay.
You understand?
Yeah. So you use the diode to separate the capacitor from the drain.
Exactly.
But what?
So the drain, it will not see the capacitor because the current is flowing only on this direction.
Oh yeah, makes sense now.
You understand?
Yes.
That's the reason why is this diode here. Okay?
Yeah.
Now let's move to buck converters. It's a weird name, I don't know.
Buck converter.
It's just another switching power supply, you know what I mean? For me, are all switching power supplies.
All right.
But that's the name, DC to DC buck converter. We have a channel N MOSFET. Simple? So it's switching this MOSFET.
All right.
Here we're gonna have the coil. And here we're gonna have the capacitor. Right? So this circuit, it will work or not? Of course, this is the output, yeah? So I have output plus. So this circuit, it will work? So with the PWM, with the duty cycle, you adjust actually the current flow through this transistor, right? Then you have a coil which is 0 ohms, then you have a capacitor to ground. It will work this circuit?
Whenever you ask, it will work. That's a tricky question.
It's a trap.
Yes, it is a trap.
It's the same way when I'm asking you, okay, what's wrong with you?
Yeah.
Nothing. Same thing. It's exactly the same thing.
So, wait.
So this circuit will work or not? Very simple. It's a simple question.
No.
Okay, why not?
You
Why
see?
not?
It must be something. It must be something.
You
But-
understand, just adjusting the duty cycle on this transistor, here you'll have voltage. You'll have from 0 to 12 volts, depends on the duty cycle.
Okay.
So, you have 12 volts here, which is going through the coil, because the coil is a wire. And here on the output you will have same voltage, 12 volts.
All right. But it's nothing there on the output.
Yeah, but, okay, you want me to connect a LED? It is matter what is on the output. Maybe I check with the multimeter. Maybe it's nothing.
All right.
So what's wrong? It will work or not? Just simple. A simple question. I just told you how it's working. You start overthinking. I just told you how it's working, this circuit. I just told you how it's working and you still don't trust me.
No, because you always like.
I just told you how it's working, yeah?
All right.
So it is working.
Yeah.
And
Okay.
I will have from 0 to 12 volts here on the output.
All right.
But this is just a basic PWM power supply. This is not a switching one.
Okay.
I mean, okay, this is charging the coil, but the coil, how is discharging? So you charge the coil, yeah, with this plus. So this plus, it will be here, plus and minus, right?
Yeah.
And then when the duty cycle is off, it will be minus and plus, right?
Yeah.
So this is kind of dangerous because you come with negative voltage on the MOSFET.
Yeah.
You understand? So basically your coil, it will bounce back. Yeah, and it will do it. But the problem is when the coil is bouncing back, this circuit, this wire is floating because the MOSFET is off.
Yeah.
That means when the coil is bouncing back, you don't have a current flow because the MOSFET is off.
Okay.
I mean, the current is not going anywhere if the circuit is not close to ground. We learned that. Yeah?
Yeah.
So you understand what's the problem with this circuit? It's not a switching power supply. It's just a PWM power supply. It's not a switching one.
Okay.
Yeah?
Yeah.
So in order to have this power supply working, you have to connect this somehow to connect it to ground.
To ground.
Yeah. And on that point, yeah, I will have minus here, will be connected to ground, and I will have plus here on the capacitor. So how we are connecting this to ground? Because if I just use a wire, then the MOSFET is shorting plus or minus.
Use resistor.
No, you
No,
can't use a
okay.
resistor on a circuit like this.
No.
You use a resistor when you want to reduce the current. So how we can do to send this to ground, yeah, to connect this actually to ground without shorting I want to connect the ground only when the coil is bouncing, not when the MOSFET is on, because if it's on and this is connected to ground, it will short the plus or minus.
You connect it with the diode. In that way.
You sure?
Yeah. Yeah.
Yeah, but you are kind of wrong.
Okay.
Indeed, his has to be a diode. But if the diode is like that, what will happen? You said the diode has to be like that, right?
Yeah.
Plus and minus. When the MOSFET is on, it will not charge the coil because the whole voltage it will goes to ground. That means the MOSFET is shorted for the diode. You understand?
So you have to put something else before the diode
No,
or after the diode?
you forgot. Yeah, when the coil is bouncing, yeah. So we charge with plus and minus. It will bounce back with minus and plus.
Yeah.
Minus, it will not flow in this direction for the diode. To have the minus flowing on this direction, the diode has to be turned around.
Opposite.
Yeah. So if the diode is opposite, the current from the MOSFET it will not flow to the diode. You understand? So only on this direction the current can flow through a diode. So in order to not short the MOSFET, I have to turn around the diode. So yeah, like that is fine. Yeah? So this is not a Zener diode. It's a normal diode, so the current, it will never, ever flow in this direction. At least this current.
Yeah.
But when the coil is bouncing back, yeah? So you charge it plus and minus. Plus is coming through this MOSFET, right? Plus and minus, yeah? The MOSFET is switching off. Then I will have here minus, here I will have plus.
Yeah.
Okay? Then I do have a current flow through the diode. You understand?
Yeah.
You sure?
I do, yeah.
Yeah?
Yeah.
Okay. Now online, if you check the videos online, it's a confusion. It's a confusion online about those power supplies. And the people believe, okay, in order to have this circuit working, you have to have a resistance here, the load. Yeah? So this is wrong. You
Why?
understand? Because you don't need a resistance in order to have this circuit working. Because the people think, okay, so it's boosting, yeah? 1 second, so it's boosting how? So we're charging plus or minus, right? How the coil is charging with plus and minus? Where is minus? Here. You have a capacitor which doesn't allow DC flow, right? Okay, so from where you get the minus, and the people think, okay, so the minus probably is coming from the load, yeah? Is wrong. This capacitor, which is a DC component, yeah, which you think, okay, it will not allow DC to flow through it, through inside, yeah?
Yeah.
Never. The DC current, it will not flow through a capacitor. A AC current, yeah, but not DC. And the confusion is like, okay, then the circuit must be like that, yeah? So pay attention here. The people think, okay, then the circuit is like that, and actually the capacitor is here just to smooth the output current, which is wrong.
So the capacitor is there.
It is partial wrong. I mean, the capacitor is doing two things. One, smoothing the output current, yeah?
Yeah.
And the second, it's actually acting as a 0 ohm resistor when the coil is charging and discharging.
So you don't need that resistor there.
No, you don't need.
Because the capacitor is acting like a resistor.
Exactly, it's acting like a short. So this circuit, it's enough, yeah, to have it working. If you have the load, yeah, the resistance here, if you have the resistance and you don't have the capacitor, this circuit, it will never work. You understand? I'm not sure you understand.
I'm not sure I understand why it will not work.
Why it will not work?
Because it the DC will go into that resistor.
On the load. The load is the load symbol is a resistor. Yeah, this is the load.
Yeah.
Because obviously every load has a resistance, yeah? Yeah. So, what do you mean?
If the capacitor...
Yeah, it will not be here.
Yeah. How that it will not work?
It will not work because you have a 0 ohm coil. You understand? And your load doesn't have 0 ohms. You understand?
Yeah.
That's one thing. The second thing, you have to understand the circuit of the current. Here we are speaking about high current. Load is not a high current thingy. Load most likely has high resistance. You know, I don't know. Anyway, it's not 0 ohms.
Yeah.
So my high current circuit is like this. Yeah. This is the high current circuit here. And obviously minus. It's not the high current for the load. No, it's from the using the capacitor. The capacitor, it's exactly a 0 ohms, a nearly perfect 0 ohms resistor.
Okay.
I'm not sure you understand,
Yeah.
but let's check together. Okay, so the theory is like that. If this capacitor doesn't allow DC to flow through it, yeah? That means if I connect the coil on the serial mode and I come with the power supply here, nothing it will happen because the current it will not flow through the capacitor. Yeah?
Yeah.
Okay, let's check together. Let's see. So we have the minus of the capacitor, yeah? We have the coil, right?
Okay.
And I will try somehow, yeah, check that, yeah? Huh? You will tell me again that this is not flowing through the capacitor? You will tell me again because exactly that's what the MOSFET, it will meet. Exactly this kind of resistance.
Okay.
So just to understand how much current was through this circuit to have that kind of spark.
A lot.
Yeah?
Yeah.
And the next spark, yeah, it will be charging the capacitor. That means the next spark, it will be like that. This it will be the next spark. MOSFET charging capacitor.
Oh.
You understand?
Yeah.
Now the next spark, it will be coil bouncing back. Like that. So you will tell me that capacitor doesn't have 0 ohms?
It does.
Yeah, you see? But obviously, if you've seen the things like, let me show this. Okay, if you've seen the things like that, like, oh, look, I'm touching, nothing happened, because the capacitor is fully charged.
Yeah.
But when you have charge discharge cycles, thousands of times per second, there is a different story with the capacitor. The capacitor is not like, okay, it's not flowing. Look, it's not flowing. It's not taking any current. It's not doing anything because this is already charged.
Oh.
What? It's a spark.
I know, but you have to tell me, hey, it's gonna be a spark.
So it is clear?
Yeah.
Now there is another confusion. Yeah, the people are confused a lot about this power supply. Then they said, okay, so let's, we have this power supply, yeah? And we set up the duty cycle and we have here 5 volts on the output, right? Okay. Now, if you have 5 volts on the output, this capacitor has 5 volts. You understand? It's not like ground. Because what we speak till now, we said, okay, this capacitor is like a resistor, 0 ohms. Now, if you have 0 ohms, it's like the same, you have the ground here. You understand? But if we have 5 volts, this is not like 0 ohms.
Okay.
Right?
Yeah.
This is a confusion. The capacitor is still 0 ohms. You know what I mean?
How?
How? Very simple. Let's test it together. So let's assume I will charge this capacitor with 5 volts. Let's assume the output voltage is 5 volts. Yeah? So the output voltage, yeah. We can check with the multimeter. Look, we can check with the multimeter. We have the multimeter on screen. It is 5 volts.
Yeah.
Yeah, okay, good. That's good. Now the MOSFET, it is switching. Yeah? The MOSFET, it is switching. It's charging the capacity. It's charging the coil, yeah? So plus and minus. Why?
Because it was
Check
spark.
there.
Yeah.
You see the spark?
Yeah.
So even if the capacitor has 5 volts, that doesn't matter. Because what MOSFET is switching 12 volts, right? So when you come with 12 volts, yeah, on one side of the of the coil. On the other side, you have 5 volts from the capacitor. Basically, you force the capacitor to charge. When you force the capacitor to charge, it will act as 0 ohms till the moment it's charging. But it doesn't have time because this switching is fast. So it doesn't matter if you have 5 volts, the capacitor, it will still have 0 ohms.
Okay.
I'm exaggerating with 0 ohms, but nearly there. Nearly to 0 point something ohms. Okay?
Yeah.
Clear?
Yeah.
Okay. Let me discharge the capacitor.
Spark it.
Ah! It's nice. It's like Christmas fireworks.
Yeah.
So you understand the confusion?
Yeah.
On a switching power supply, yeah, which is kind of like AC, the capacitor is acting as a resistor. So one, yeah, just to understand what this capacitor is going through. So once, yeah, the coil is charged, then after that is bouncing back. And this capacitor is taking bumps, bump after bump. That's why those capacitors, especially like in a big power supply, like TV power supply, those capacitors are dying first.
Poor capacitor.
Yeah. Okay, so you understand how it works?
Yeah.
Good, because next time we're gonna build this.
Okay.